Okay, we're going to continue our section on linear relationships by talking about independent and dependent variables. Many real-world situations involve two variable quantities in which one quantity depends on the other. These quantities are called independent and dependent variables. It is important that you be able to identify the independent and dependent variables in a linear relationship when given a situation, table, graph, or equation. So in your notes, go ahead and write down these two definitions, please. The independent variable may have its value freely chosen without considering the values of any other variable. So the clue word for independent is freely, actually there's two clue words, freely chosen. Freely chosen. It means you can choose any value for the independent value, or for the independent variable, and it's not going to really make a difference. It's okay to do that. The dependent variable, however, depends on the other variable. It depends on the independent variable. You cannot determine its value without first knowing the value of the independent variable. Turn to page 3 in your packet, and let's go ahead and practice identifying independent and dependent variables. The first one is actually an example that has been done for us, so let's quickly go through it. Peter coaches soccer clinics that charges $15 per player. T stands for the total amount of money he makes, and P stands for the number of players that sign up. We need to identify the independent and the dependent variables. First thing, identify the variables you're given. T. T stands for the amount of money he makes. And our second variable is P, which stands for the number of players that sign up. Okay, so go back to the independent variable. What can freely change? Which variable can we freely change the numbers of? Okay, can we freely change the total amount of money he makes? Or can we freely change the number of players that sign up? P, we can freely change the number of players that sign up. There could be 3 players that sign up. There could be 10 players that sign up. There could be 25 players that sign up. That can freely change. But what cannot freely change is the total amount of money, because that depends on how many players are going to sign up. If 3 players sign up or 25 players sign up, Peter's going to make a lot more money if 25 players show up than 3 players. So the T, the amount of money he makes, depends on P, the number of players that sign up. Okay, let's do number 1. Mr. Macker's soccer team is having a car wash to raise money for new uniforms. W stands for how many cars are washed, and C stands for how much money they raise. So we need to think about what can freely change. Can we freely change the amount of money they raise, or can we freely change how many cars they wash? Well, hopefully you said we can freely change how many cars. They could wash 2 cars, they could wash 10 cars, they could wash 50 cars. But how much money they raise depends on how many cars they wash. They're going to raise a lot more money washing 50 cars than they are going to wash 2 cars. So that dependent variable, we're going to fill this in, should be C. C, money raised, and I'm just going to abbreviate here. It depends on our other variable W, which is how many cars are washed. Okay, example 2, number 2. Tara uses her cell phone a lot and she gets charged 5 cents a minute. C stands for the total that she pays, and M stands for the number of minutes she uses. Alright, so here we go. Which one can freely change? Hopefully you said M, the number of minutes used. You're not going to know the total amount she has to pay unless you know the number of minutes she uses. So the dependent variable C, which is total pay, is going to depend on M, the minutes used. And number 3, Yvonne reads about 20 pages a night before she goes to bed. N stands for the number of nights she has read, and P stands for the total number of pages. So again, what can you freely change? Can you freely change the number of nights she has read, Or can you freely change the total number of pages? The number of nights, that can be changed. She could maybe read 2 nights a week, or she could read 5 nights a week. That can change. But the total number of pages, you can't change it, or you can't determine its value unless you know the number of nights. So here we go. P, their dependent variable is going to be P, which is, P, total pages, is going to depend on N, the number of nights read. Okay, so in your journal for these 3 situations, I want you to go ahead and identify the independent and the dependent variables. Just pause the video. Once you've identified the independent and dependent variables, come back and check to see how you did. Okay, in our first example, you burn 14 calories every minute you exercise. The 2 items that you're comparing here, are 2 variables, are going to be the calories burned, total number of calories burned, and the total numbers of minutes exercised, or the total number of minutes exercised. Okay, which one can freely change? Well, you can freely change how many minutes you exercise. You could exercise for 30 minutes or 60 minutes or 90 minutes. But you're going to need to know how many minutes you exercise to determine the number of calories. So your dependent variable is the number of calories burned, and your independent variable is the number of minutes exercised. In our second example, 2 slices of pizza per person. Okay, think about it. We're talking about the number of slices we need and the number of people. Which one can change? The one that can freely change is the number of people. Okay, how many people are eating pizza? You need to know that before you can determine how many slices of pizza to buy. So your independent is the people, the number of people, and your dependent would be your slices of pizza. And the last example, $7.50 per movie ticket. So the 2 things we're talking here is we're talking about the total cost, and we're talking about the number of movie tickets. Okay. You're not going to go into the movie theater and say, oh, give me $25 worth of tickets. Okay, that's not your independent. Your independent is how many tickets you want to buy. I want to buy 5 tickets. I want to buy 3 tickets. That's what can freely change that number. So the number of movie tickets is your independent, and your dependent is your total cost. How much total is going to cost you for the number of tickets you want to buy. Okay, so let's talk about where you are going to find the independent and the dependent variables in graphs. Okay, this is pretty easy. In graphs, we know that an ordered pair is going to be xy, the x coordinate and the y coordinate. And the x comes first. You need to know where to place the x coordinate. You might know what the y is, but unless you know what the x is, you cannot place that point on your graph. So the x is going to be your independent. So you need to write that in your notes. The x coordinate is your independent, and your y coordinate is going to be your dependent. That is never going to change. The x-axis, the horizontal axis, this is always your independent, and your y-axis, the vertical one, is always your dependent values. So looking at this right here, we can easily see that the clay bought by the teacher is our independent because it is on the x-axis, and that the clay that's available for the classes is your dependent because it is on the y-axis. But you need to make sure that you can justify it, that you understand it. You have to know how much clay the teacher bought in order to determine how much is going to be available for each class. Look at the second graph. We have time and hours is on our x-axis, the horizontal axis, and this is actually supposed to be total cost is on the y-axis. Okay, so again, we know that the time is going to be the independent because it's on the x-axis, and that the dependent is going to be the total cost. But if you think about it, you can't know the total cost unless you know the total number of hours spent. Or it could be pay, total pay, and number of hours worked. Okay, you have to know the time to determine the total pay, or the total amount. And let's look at some tables, what it would look like in tables. Okay, usually in a table, the first column or the first row, depending if you have a vertical table or horizontal table, usually that first column or the first row is going to be your independent, your X. And usually the second column or the second row is going to be your Y, your dependent. So take a look at the first one. A freight train moves at a constant speed. The distance Y in miles that the train has traveled after X hours is shown. Okay, so just to make sure, why would the time in hours be your independent? You need to justify this. Why? Well, we need to know how many miles, and to determine the miles, we have to know the time. So the miles, the distance, is dependent upon the time. We can change the time. We can just travel for 1 hour. We could travel for 3 hours. But our distance is going to depend on the time. I can't say, oh, I'm going to travel 1 hour, I'm going to travel 150 miles, and that's going to equal an hour, because that's not true here. The amount of water needed for a hike. Cups of water, the number of hours. Okay, well, in this case, they switched them, didn't they? They have the number of hours, the cups of water. If you're going to go on a hike, you want to figure out about how long it's going to take you, so you know how much money to bring. So really, this number of hours should be our independent. And then the cups of water is going to be the dependent. And same thing for this table down here, money earned and hours worked. You need to know how many hours you're working before you can determine the money that you earn. So the hours can change. You could work 3 hours, you could work 10 hours, but that's going to be your independent, and the money earned is going to be your dependent. So again, even though usually your first column or first row is your independent, sometimes they're going to be switched around. And that's why it's important to actually justify why you're choosing one as your independent and the other as your dependent. So let's look at your homework for tonight. Homework is page 5 and 6. So on page 5, we're going to look at number 1 and number 3. Okay, number 1 is the table. We need to identify the independent and the dependent variable, and we have to justify the answer. Okay, so the independent variable, we have the number of people, the money earned. Okay, this is for a concert profit. A concert profit. So to know how much profit you're going to make, you have to know the number of people that are going to attend your concert, right? So the independent variable is going to be P, the number of people, and then your dependent variable is going to be M, the money earned. So to justify your answer, you need to write, you need to know how many people attended the concert to determine the money earned. You can't say, oh, I want to earn $2,000. Because what if 250 people don't show up? Okay, then you're not going to make your $2,000, are you? So that money earned, that's your dependent. Okay, let's look at our graph. We definitely know for sure that our independent is P, the number of people, and our dependent is the number of tables, T, and we know this because P is on the x-axis and the number of tables, T, is on the y-axis. But now we need to justify that. Okay, we need to justify that the number of people is the independent. Well, think about it. If you're going to have a party, a big party, maybe a wedding, okay, you need to know the number of guests or the number of people to determine the number of tables you need to have, don't you? So justifying it, you're going to write, need to know the number of people to determine how many tables will be needed. This is what you're going to do for your homework. You're going to identify the independent and dependent variables from the graphs and the charts, from the tables, and then you have to justify your answer like we've done here.